Welcome to episode 23 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Imagine teaching a machine how to spot patterns without spelling out every single rule. That's the heart of how machines learn today.
Yeah, it almost feels like magic, right? But behind that magic is a world of clever methods we call machine learning.
Exactly. So let's start by breaking down what machine learning really means. In simple terms, it's about building algorithms that can learn from data. Instead of programming explicit instructions, we design systems that improve their performance over time by recognizing patterns.
And that's a big shift from traditional programming where you tell the computer exactly what to do step by step. Machine learning is more like showing the computer lots of examples and letting it figure out the rules on its own.
Right. At its core, you have three main components: algorithms, patterns, and models. An algorithm is a set of rules or calculations the computer follows. Patterns are the interesting relationships or regularities found in the data. The model is the outcome, a mathematical representation of those patterns that the machine can use to make predictions or decisions.
I love that breakdown. In practice, I often see business leaders a bit fuzzy on what a model really is. They think of it as some mysterious black box, but really it's just the what the machine has learned from the how we programmed it and the data it consumed.
That's a good point. Another way to think about it is like training a dog. You don't teach the dog a complex set of instructions in one go. Instead, through repeated exposure and rewards, the dog picks up patterns of behavior. Similarly, a machine learning model learns from data examples and feedback.
I like the dog analogy. And in the real world, this approach opens up so many possibilities. For example, in automotive, companies use machine learning to detect defects on production lines by recognizing patterns in images, instead of having an engineer specify every possible flaw.
Interesting you mentioned that. Historically, early AI systems were all about hand-coded rules, experts literally writing all the logic. This worked okay for narrow tasks, but was incredibly limiting. Machine learning emerged as a way to overcome these limitations by leveraging data to build models that can generalize.
That's been a game changer in retail too. Think about recommendation engines on e-commerce sites. They analyze customer behavior patterns to suggest products without humans having to define which items go together. It's learning from the data patterns that drive practical sales results.
Exactly. And the variety of algorithms available is vast. Some are simple, like linear regression, which fits a straight line to data points. Others, like neural networks, mimic the human brain structure to capture complex patterns.
It's quite fascinating how these algorithms work differently depending on the problem. For example, I recently worked with a healthcare provider using decision trees. These are models that basically split data based on yes-no questions to diagnose patient risks. Straightforward, but very effective.
And that highlights an important point. The choice of algorithm depends on the data, the problem, and the goal. There's no one-size-fits-all, which is why understanding these basics is so useful.
Agreed. Another aspect is the quality and quantity of data, the fuel for these algorithms. Without good data, even the best algorithms fall flat. This is why companies invest heavily in data cleaning and collection up front.
Yes, the saying garbage in, garbage out applies strongly here. The model can only be as good as the data it learns from. This also leads us to the idea of training and testing. We train models on one chunk of data and test them on another to see if they can generalize beyond what they have seen.
Testing reminds me of a project I handled for a finance client that used fraud detection. They trained the model on historical transactions and then tested on recent ones. If the model flagged too many false positives, meaning legit transactions, it would hurt customer experience. Balancing accuracy is a real challenge.
Absolutely. And this challenge is precisely why machine learning requires a fine blend of theory and practice. You have to understand the algorithms and their assumptions, but also how they behave with real-world data and business impacts.
Speaking of impact, I also want to stress how machine learning isn't just for tech giants. Mid-sized companies in retail, manufacturing, even local healthcare providers are increasingly adopting these techniques to gain competitive advantages, like optimizing inventory, predicting equipment maintenance, or personalizing patient care.
That broad adoption shows how foundational machine learning has become. It rests on the simple but powerful idea that data holds clues to better decisions, and models help us uncover them.
One thing I sometimes see is companies rushing into buying fancy machine learning tools without fully understanding these basics, which leads to misaligned expectations or projects stalling.
That's a classic pitfall. Without a grounding in what machine learning is and isn't, it becomes easy to think it's a magic wand, rather than a method that requires thoughtful design, good data, and evaluation.
Yeah, and that understanding helps set realistic goals. For example, using machine learning to completely replace a human expert off the bat rarely works, but using it to augment human decision-making often delivers significant value quickly.
Definitely. And as we'll discuss in upcoming episodes, there are different categories of learning, like supervised, unsupervised, and reinforcement learning, which change how the machine receives input and feedback.
Which is exciting because businesses can then choose approaches that fit their data and objectives, from spotting customer segments with unsupervised learning to guiding robots with reinforcement learning.
To wrap up, let's summarize our key takeaway.
Sure. For me, the key takeaway is that machine learning is a practical approach where machines learn patterns from data using algorithms to build models. And this fundamentally changes how businesses solve problems.
Well said. And I'll add that understanding these basics, algorithms, patterns, and models is essential for anyone who wants to confidently engage with AI and data-driven initiatives.
Up next, we'll dive into supervised learning, probably the most common type you hear about, where models learn from labeled examples.
That one's foundational because it shows how providing the right examples guides machines to make accurate predictions.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd also love to hear your thoughts or questions about machine learning. Send them our way and you might hear them in future episodes.
Thanks for tuning in.
Until tomorrow, stay curious, stay data-driven.